Students, coming to the next topic, that is the demand paging. So this is one of the virtual memory concept. So the CPU wants to demand the page from main memory. So if it is present, let us see what is this demand paging. It is quite similar to the paging concept. So the demand paging is both are quite similar to the paging systems with swapping, where process resides in secondary memory and pages are loaded only in demand, not in advance. So actually here the process resides in secondary memory. Secondary memory means the disk. So actually the process, everything will be present, resides in the secondary memory, and pages are loaded only on demand, not in advance. So actually the main memory is starting whenever you switch on the computer. The main memory, that is, everything will be free. Means that the main memory is nothing but a RAM, okay, random access memory. Whenever your system is on, the RAM is free. So whenever the process, the process are present in the secondary memory. So and the pages are loaded to the main memory only on demand, not in advance. So whatever the page you are opening, means whatever the folder you are opening, so that is present in the secondary memory. That opened folder, that will be stored in the main memory. So it will be, everything will be stored on the basis of demand, not in advance. So that you call it as demand paging. So the processor, the CPU wants to execute, suppose if it wants to retrieve a file from the secondary memory. So first, whenever that it goes to the secondary memory and bring that page or a frame to the main memory. Let me explain with an example there. So let us take, this is the main memory. So main memory consisting of process P1 and the P2, two processors. So each process having some frames A, B, C, D, like that. And the process 2 is having E, F, G, H. So the main memory is having, already it is full, this having the frames. And coming to the secondary memory. Secondary memory is the disk. This is the secondary memory. So the secondary memory consisting of, suppose A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. Okay, so this is the pages that are present in secondary memory and the main memory. So whenever the processor is demanding for process P1, that data will be stored in main memory. So at starting, all the frames are free. The data, that is the main memory, is free. So whenever the CPU demands for process 1, P1. So this is the P1, this is P2, let's take this is the P3, like that. So whenever the CPU demands for P1, so the data that is present in the secondary memory will stored in main memory, A, B, C, D. Okay, suppose if you want to store these data, some data in the process P2, but here it is already full, the process P2 is already loaded in the main memory. If there is no space in the main memory, you just, if you are not using process P2, okay, you just send the data to the secondary memory and takes the new data. Okay, so now I want to swap out this process. So this is the swap out. So whenever there is no use of pages in the main memory, if you are not using those frames in the main memory, you just again send that data to the secondary memory and take the new data. So whenever this operation is over in the main memory, you can again swap in the already swapped out data. So this is the swap out. and this is the technique of swapping. So it is just similar to the paging system with swapping. So the demand paging is everything is depends upon the swapping. So you have to demand the page from secondary memory. The CPU is demanding the page from secondary memory. Suppose when the main memory is not free, you just swap out the pages that are not used in the main memory and place the new pages in the main memory. So when we want to execute a process, just swap in. If you want to execute the process, just swap in. If your execution is over, just swap out. Don't bring the pages in advance. So the process resides in secondary memory and pages are loaded only on demand, not in advance. So that is the concept of demand paging. So while executing a program, if the program refers a pages, okay, while executing the program, if the program refers a pages which is not available in main memory. Suppose if I want some page, so that page, suppose I want the E page, so which is not available in main memory because it was swapped out little ago. So I just swapped out, but it is not present in the main memory. But CPU is asking for E page. Okay, the CPU is asking for E page, but it is already swapped out. Then the processor treat this invalid reference as a page fault. So if the page is not present, in main memory, then we call it as page fault. When the demanded page, the CPU demands the E page, but E page I already swapped out to the main memory, but the CPU is asking for the E page. So if the demanded page is not present in the main memory, then we call it as a page fault. Okay, so what does the processor will do if the page fault is occur? Okay, the CPU wants E page, but that E page is not present in the main memory. Then the CPU transfers a control from program to operating systems to demand the page back into memory. So CPU transfers transfers control from the program to operating system. So not like that, let me write that. So if the page fault occurs, CPU transfers control from program to operating system to demand the page back into main memory. So that is a concept. Okay, see, suppose the CPU is requesting for page in main memory. Okay, suppose the page is not present. So whatever the requested page in the main memory, that is not present. So if it is not present, it calls as a page fault. So then the control transfers to operating system. So what this operating system will do? Operating system go back to disk, that is a secondary memory. Again place that into main memory. So this is a concept of page fault. So in the demand paging, we came across the page fault. So whatever the CPU is demanding the page, if that page is not present in the main memory, so that you call it as a page fault. So to overcome this page fault, what the CPU will do? The CPU transfers the control from the program to the operating system. Then the operating system demands the page back from disk to main memory. Okay. So let me write about the page fault. So what exactly this page fault with an example, so that I'll explain the next video. Thank you.